Hello everyone, here we have an interesting problem of the projectile motion. At what angle this particle must be projected so that the area under the trajectory is maximum. I request you to post your opinion in the comment box and I am doing the detailed solution over the board. The concept is simple. Suppose we fire a projectile like this at this angle, then there will be some area under this curve, under this path. Got it? Suppose we change the angle and we fire it like this, then there will be some area under the curve. Okay, we fire it like this, again there will be some area under the curve. So the idea is pretty simple. For different angles, the area under the trajectory is different. You got it? How we will get that angle for which the area under the curve is maximum? We'll be using the concept of maxima and minima. First of all, we'll find the area as a function of theta, okay, and then d by d theta of the A should be equal to 0. Using this, we'll get the value of theta. Okay, if you wish, you can proceed in this manner and report your answer in comment box. First of all, find the area as a function of theta, then maximize that function and you'll obtain the value of theta as 60 degree. That will be our final answer. Suppose we take up this as the x-axis, this as the y-axis, and the particle is thrown at some angle theta, okay, with the horizontal. The projection speed is given as u, and this u has two components. One component along the x-axis we call it ux, another component along the y-axis we call it uy. Our target is to find the area under the curve. For that, here is the origin 0, 0. We go at a distance x, and at this distance x, we take up a very small width dx. This very small width is dx. Got it? So the coordinates of this point are x, y. This distance is x, this distance is y. Here we have a very small rectangle. Look at this rectangle. Can you tell me the area of this small rectangle? Yes, it's simple. Its area, the dA, will be written as what? Width is dx and height is y. So y dx. I hope you agree with it. To obtain the total area under the curve, will integrate it from x is equal to 0 to x is equal to r, or if we are integrating in the terms of time, then from t is equal to 0 to t is equal to capital T, where capital T is what? 2u sine theta by g, the time of flight. Okay, now let us obtain the y as well as this dx. We know one thing, this x will be equal to uxt plus half of axt square, and there is no acceleration in the x direction because the only force in this case is the gravitational force which is acting in vertically downward direction. Okay, acceleration due to gravity is like this. So ux is known to us. U will have a component here in the horizontal direction. That component will be u cos theta. Here we have the x, and if we differentiate that x with respect to time, the dx by dt will be equal to u cos theta d by dt of t. Do you agree with this? I am differentiating with respect to the time. So the dx by dt comes out to be u cos theta. Basically this is ux only. Okay, and the dx comes out to be u cos theta dt. Done. Next we are obtaining the y coordinate. In order to obtain the y coordinate, I am using the second equation of motion since the acceleration in the y direction is constant. So the y coordinate will be equal to u sine theta t plus half of minus g into t square. Which equation of motion? Second equation of motion. The initial velocity in the y direction is positive and acceleration in y direction is in the negative direction. We choose the convention upward positive, downward negative. That's why here is a negative sign. Now I have the y as well as I have the dx. So let's submit them here. Putting up the data, the y is equal to u sine theta t minus gt square by 2. Okay. And the dx is u cos theta dt. This is the dA. If we need the total area, we'll integrate both sides. Here the limit varies from 0 to a. And here we are integrating with respect to time t. So the limit of time varies from 0 to capital T. Here is 0, here is capital T. Got it? If we take the limit of time from 0 to capital T, this total area under the curve is taken into account. Let's proceed further for the integration. Simplifying this, so u into u is u square. Then we are left with sine theta cos theta, and here is t dt. Limits are from 0 to capital T. Then next minus g by 2 u cos theta, and we are left with integration of t square with respect to time. Limit is from 0 to capital T. Is it okay for everyone? In LHS, we'll be getting the complete area A. So A comes out to be this. I'll keep as it is u square sine theta cos theta. Integration of t, I hope you remember, it will be t square by 2, and when we put the limits, it will look like this. Okay, going further, minus g by 2 u cos theta, and here what we will get? We'll get t cube by 3 minus 0 cube by 3. That is also simple expression, and t is already with us. So I am submitting this value of t, putting here the value of t as well as here, and simplifying this expression. So the A is equal to u square sine theta cos theta, and this 2 I am taking outside. T square will be what? Speak up. 4 u square sine square theta by g square. Okay, minus g by 2 u cos theta. This 3 I am taking outside here, and then we are left with t cube. How much is t cube from this computation? It is 8 u cube sine cube theta by g cube. Done. Now you can see something common in this expression. This sine theta and sine square theta will make sine cube theta. Here is also sine cube theta. G is present in both the expressions. So I am taking out few things, few parameters common. Just pay attention. So first of all, I am taking this u to power 4. U to power 4 is available here, as well as this u to power 4 lies here also. Look at this part. I am taking that u to power 4. Then I'll be taking up the sine cube theta. Sine cube theta from here and here common. Got it? Now here we are having the term of g square. This g and that g cube. Here also we will be having the g square in the denominator. So taking up that g square. Is it okay for everyone? Then we can take up 2 also outside. 2 and 4. Here in the numerator will be 2. I am taking that 2 outside. Now check what is left here. The 2 has been taken outside. This is effectively 2. Okay. u to power 4 has been taken outside, the sine cube theta has been taken outside common, so we are left only with the term of cos theta here. Is it okay? Or even I can take this cos theta also outside to make the expression look further simple. Now this cos theta is also taken common, so here we are left with what? Only 1. Okay, everything has been taken outside. Now I'll be simplifying the things here. Minus sign lies there. This g square has been taken common. U to power 4 has been taken outside. The sine cube theta cos theta, that also has been taken common. Can you tell what is remaining here? The 2 is also taken common here. So here in the numerator, what we are left with, the final expression here is 2 by 3. Check it once yourself. I think it's pretty simple maths. Okay. 1 minus 2 by 3 is what? 1 by 3. So I can write the final expression of the area here. It comes out to be 2 by 3 u to power 4 g square sine cube theta cos theta. And you can check it dimensionally also. The area will have the dimension of the meter square, and we can verify this. Sine cube theta is dimensionless, cos theta is dimensionless, 2 by 3 is also dimensionless. If we write the units of u is the speed is in meter per second. So here what we are left with, meter per second to power 4 in the numerator, and in denominator we have the g square. G is acceleration. Acceleration is taken in meter per second square and then square. You can check it yourself. Second to power 4 and second to power 4. What's happening to it? It is getting nullified. Meter to power 4 and then meter square. So final result here left, if we check dimensionally, this comes out to be meter square. It means computation is correct. Suppose this question comes in objective pattern, and if the dimensions of some options are wrong, then obviously those options are incorrect. This option is dimensionally correct. Now our next target, since we have the area as a function of theta, we are going to maximize this area for some particular theta. Okay. So I'll be continuing that on the next screen. If you wish, you may take a note of this. Then remaining calculation will do further on the next screen. Now proceeding further for the final answer, area is a function of theta only. Why? Because if you check the language of the question, this u is already given, it is constant. This 3 is constant, 2 is constant, g square is also constant. So area is a function of theta only. I am going to maximize this area. So for that will require first the dA by d theta or d by d theta of a, whatever you pronounce it, is equal to, this all is constant, so it is kept outside of the differentiation, 2 by 3 u to power 4 g square, and we are going to differentiate sine cube theta and cos theta. You can check these two terms are in multiplication. I hope you remember the way of the differentiation of such things. So I'll keep the sine cube theta and then I'll differentiate the cos theta. Then we'll put a positive sign. We'll keep the cos theta outside and we'll differentiate the sine cube theta. I'm proceeding here for the differentiation further. dA by d theta, this constant term has been kept aside, 2u4 by 3g square. Keeping the sine cube theta and differentiating the cos theta, plus keeping the cos theta aside and differentiating the sine cube theta. Is it okay? You might remember the results. Speak up. What we should write next? Differentiation of cos theta with respect to theta is minus sine theta, plus first of all we'll differentiate this power 3. So its differentiation will be 3 and the entire data power 3 minus 1 into d by d theta of sine theta. Is it okay? We differentiated the outside function and then we are differentiating the inside function. This is the differentiation of outside power and this is differentiation of inside function. So now the things are simple. 2u4 by 3g square. We are left here with minus sine to power 4 theta plus 3. This differentiation of sine theta, we remember that is equal to cos theta. So 3 cos square theta and sine square theta. Is it okay for everyone? This is dA by d theta. We can simplify this further. Sine square theta can be taken common outside. So we are left with 2u to power 4 3g square sine square theta. Then in this term we are left with minus sine square theta and in this term we are left with plus 3 cos square theta. Now if we want to maximize the area, this dA by d theta should be 0. This u is non-zero to 3g square, even the sine square theta is also non-zero because the theta is not equal to 0 in this case, in this question. So this entire term, if we check carefully, is not equal to 0. If this entire term is not equal to 0, then which term must get 0 in order to obtain the 0 in the LHS? Obviously, this term should be equal to 0. So technically here we have minus sine square theta plus 3 cos square theta. I hope this computation seems simple to everyone. I am taking the sine square theta in the left hand side. So we are having sine square theta is equal to 3 cos square theta. And it's pretty simple computation now. Tan square theta comes out to be 3. And here is the final answer. Theta should be equal to 60 degree. I hope you remember that tan 60 degree is equal to root 3. For the given speed u, if the particle is starting making an angle 60 degree with the horizontal, then the area under this trajectory will be maximum. This area will be maximum. Got it? I hope you enjoyed this result. If you have any doubt or any query, let me know in the comment box. Stay awesome. See you again.